Welcome to level 2. Let's get started. You have 2 fluorines. You have 2 hydrogens, 1 oxygen, 2 fluorines, 1 hydrogen, 1 fluorine. What you notice here is that you have hydrogen and oxygen on both sides. And I like to tell students, if you have hydrogen and oxygen, save those for the end. So that leaves us with fluorine. We see that we have 2 fluorines on the reactant side, and we have a total of 3 fluorines on the product side. What we need to do is get that odd number to become even. And the only way to do that is to work on this fluorine here. 1 fluorine is the odd number, so we put a coefficient of 2 here. Now we have a total of 2 fluorines plus 2 fluorines, which is 4. What do I multiply this 2 by to get 4? We multiply it by 2. So double check, I have 4 fluorines. I have 2 fluorines plus 2 fluorines, which is 4. Now I have hydrogen and oxygen. Neither one of them are by themselves. They're in a partnership with something. So let's just look at them first. I have 2 hydrogens here. I now have 2 hydrogens there. These match. Here I have 1 oxygen in water, and I have 1 oxygen in oxygen difluoride. They match. Everything then is balanced. My ratio is 2 to 1 to 1 to 2. Let's look at number 2. You have 1 sulfur, 2 oxygens, 2 hydrogens. 2 hydrogens, 1 sulfur, 2 hydrogens, 1 oxygen. Again, you have hydrogen and oxygens on both sides, so let's take care of the other element first, that other element being sulfur. On the reactant side, you have 1 sulfur. On the product side, you have 1 sulfur. Now you have to take care of the hydrogen and oxygen. What I like to encourage kids to do is recognize that over here, hydrogen is by itself. So let's take care of oxygen first. Here on the reactant side, you have 2 oxygens. On the product side, you have 1 oxygen. We have to multiply this guy by 2. Now I have 2 oxygens on the product side. I have 2 oxygens on the reactant side. That leaves us with our hydrogen. My hydrogen on the reactant side shows 2 hydrogens, but on the product side, I have 2 hydrogens plus 4 hydrogens. 2 times 2 is 4. So 2 plus 4 is 6. So that means I have to have a coefficient of 3 to get 6 hydrogens. So now my ratio is 1 to 3 to 1 to 2. Moving on to number 3. We see that we have 1 carbon, 2 hydrogens, 1 oxygen. 1 carbon, 4 hydrogens, 1 carbon, 2 oxygens. Again, we have hydrogens and oxygens in this formula, so let's deal with everything else first. Let's look at our carbon. On the reactant side, we have 1 carbon. On the product side, 1 carbon plus 1 carbon, which is 2 carbons. What do I multiply this guy by to get 2 carbons? We need the 2. So now we have 2 carbons on both sides. We see that we have water and we have this methane and this carbon dioxide. Neither hydrogen or oxygen are by themselves. So now you have a 50-50 shot of where you want to start with. So I'm just going to go with a hydrogen because that's next in the list. Here I have 2 hydrogens. On the product side, I have 4 hydrogens. What do I multiply 2 by to get 4? We need a 2. So now I have 2 carbons. I have 2 carbons. 1 plus 1 is 2. I have 4 hydrogens. I have 4 hydrogens. I have to distribute the 2 through to get to my oxygen. I have 2 oxygens. And now on my product side, I have 2 oxygens. My ratio here is 2 to 2 to 1 to 1. I am balanced. Let's look at number 4. You have SO2 plus H2 produces S plus H2O. Start with our sulfurs first. 1 sulfur, 1 sulfur. Now, who would I want to take care of first? Well, I'm going to say let's take care of my oxygen first because this hydrogen is off by itself. So let's take care of oxygen. I have 2 oxygens on the reactant side, and over here I only have 1 oxygen. That means I need a coefficient of 2. I've got to distribute it through. Now that gives me a total of 4 hydrogens. So on the reactant side, I need 4 as well. So I need a coefficient of 2. I am now balanced, and my ratio is 1 to 2 to 1 to 2. Now the bottom one is a combustion reaction, and we're going to talk about types of reactions next week. But combustion reactions tend to be the trickier ones to balance. This one, I did not try to trick you, but I will show you how it gets a little bit harder next week. I say this is a combustion reaction because what I have is a hydrocarbon. I have a carbon-hydrogen molecule, and I'm adding some oxygen gas to it, and it produces carbon dioxide and water. Okay, so we got some fire that's happening here. But just like we've done in the past, because you have hydrogen and oxygen on both sides, you want to start with the carbon first. Here I have 2 carbons, and on this product side I have 1 carbon, so I need a coefficient of 2. Now because I have oxygen here by itself, that means I'm going to leave it for the end, and I'm going to balance my hydrogens first. So I have 4 hydrogens, and on the product side I have 2 hydrogens, so I need a coefficient of 2. So 2 carbons, 2 carbons, 4 hydrogens, 4 hydrogens. Now I got to take care of my oxygen. So 2 times 2 is 4, plus 2 times 1, which is 2. So 4 plus 2 is 6, and I need a coefficient of 3, and we are balanced. So we would record these if I was talking to somebody. I would say, hey, I'm in a 2 to 1 to 1 to 2 ratio. Right? And on number 2, I would say I'm in a 1 to 3 to 1 to 2 ratio. And on number 3, I would say I'm in a 2 to 2 to 1 to 1 ratio. And on number 4, 1 to 2 to 1 to 2 ratio. And number 5, I'm in a 1 to 3 to 2 to 2 ratio. Good luck with level 3. Talk soon.